Welcome to Brew by Databricks with Denny and Brooke. The series allows us to explore various topics in the data and AI community. Whether we're talking about data engineering or data science, we're going to interview subject matter experts to dive deeper into these topics. Meanwhile, we're enjoying our morning brew. My name is Denny Lee. I'm a principal developer advocate here at Databricks and one half of Brew.
Hi, and my name is Brooke Wenig, director of our machine learning practice at Databricks and the other half of Brew. And today we are thrilled to have Andrew Drozdov, a research scientist at Databricks with a focus on RAG and in particular retrieval, to tell us all of the things about how to be doing RAG and retrieval better. So welcome, Andrew.
Yeah. Hi, Brooke and Demi. It's great to be here. I know you all through work, but it's kind of fun to have another opportunity to hang out and chat about interesting things.
Definitely. Andrew has been super helpful with helping my team out on customer engagements and customer projects. And today I'm hoping you can enlighten all of our listeners about what are some tips and tricks for doing RAG well. And perhaps let's just start off with what is RAG and what are the main areas that people can be looking to improve their RAG systems?
Totally. So yeah, RAG is Retrieval Augmented Generation for folks that don't know the abbreviation. It's pretty cool. I'm like really excited about RAG. You know, fortunately, we have these really cool AI models, like these large language models, and they've been trained with lots of data, but they haven't been trained on everything, and they're kind of out of date as soon as they're released. So yeah, RAG lets us kind of inject useful information into the prompts so that language models actually have a chance of getting, things correct about the latest, most difficult and interesting questions that we're asking them.
Mm-hmm. And so to be able to retrieve this context to then pass into a generative model, what is the first thing that people typically do wrong? Would love for this to just be a learning session. Like, what do people typically do wrong when they're embedding their documents, chunking them?
There's like really a lot of different components to RAG. I think in the simplest setup, you would embed all of your documents. Like we were just talking about maybe a simple setting. You're not doing web scale search. You just want to search over a few of your documents for your team or maybe the documentation of like some new coding library that you're using. And you would embed all these documents, and let's keep it simple. Let's just say they're already nicely organized and simple to embed.
Yeah, we'll pretend it's actually clean data. Let's just, for sake of argument. Yes.
Yeah, let's pretend.
Okay.
So next, you want to ask a question and generate an answer. And what you'll do is embed your query now, compare that against like the document embeddings, find relevant documents, and then take a few of those, like the text for those documents, put it in the prompts and with the original question, and then generate an answer. So I kind of described high level, kept it very simple, right? Clean data. One of the things that immediately you can start doing a little bit better is to generate like a better query. And this is like the type of stuff I'm really excited about. Like I found that one of the major bottlenecks in RAG applications is you're just not finding the right thing. And I think it's hard both for like practitioners who are like using the latest, greatest tools and they're trying to figure out how to get good quality out of their RAG system. But it's also hard for AI people where they're used to training, like simple input output models. And they're maybe less familiar with IR, and they're used to, tuning hyperparameters and looking like at loss numbers go down. But kind of the magic about search and IR is if you find like the right piece of information, that's like 99%. Like you're basically there now. And it's kind of amazing how so many questions that we have, it's not really like you need to aggregate information from lots of sources. It's just like that, the answer to your question is just like in a document somewhere. It's just there. You almost need to like copy it from that document to the output, like a huge chunk of the time. So long answer to a simple question of, how to improve the RAG pipeline. But if you can just like improve your query, maybe use the language models to actually rewrite your query so it looks more like a query. That's already a pretty good way. Because like people, they get very conversational, right? They're like, "Hi, ChatGPT," or "Hi, DBRX, how are you doing? I have this question today." They get very detailed, and you really sometimes just need a few keywords from that to find the document that you care about. Yeah.
I'm curious though, but I was under the impression that, for example, you sometimes do though want to provide a little bit more detail. For example, I mean, the fun one that I use is when I my version of testing an LM, by the way, is the what I what colloquially call the bagel test. You being a New Yorker will disagree with wholeheartedly with what I'm about to say, which is basically I'll ask DVRX or Llama 3, which bagel's better, New York versus Montreal. If they answer Montreal, then I know it's the correct, it's the correct the LM's actually worth me working with now. And then so I'm not
I'll
trying to start a
keep your
debate,
mouth shut.
I realize that. But then also, like, to my actual question outside of just, pegging you on here, right, is like, for example, I go ahead and toss it a system prompt that says, "Hey, go ahead and answer this question like you're Anthony Bourdain." So that way there's a lot of snark and sarcasm. So I'm just curious from your perspective, like, what's that balance of, like, sometimes, just like you said, sometimes providing the right amount of information so that way it's like an IR problem, versus sometimes you actually do need to provide additional information that actually is still somewhat helpful as opposed to making things worse, right? In terms of when you're doing that information retrieval.
Right. So by the way, immediately, no matter what I say now, uh, this isn't even about the bagel thing. Of course, that's part of it too. Um, I'll just treat it like a generic problem and not I'll pretend like I'm not a domain expert here. Yeah. So, but no matter what I say, we're all gonna get in trouble because like we're calling it like an IR thing, and now this is me getting pedantic
Oh, okay, fair enough, fair
of
enough.
I started going to IR conferences somewhat recently, like within the last couple of years, and IR, like the IR world is like it's a lot bigger than like just search, I guess, or they think of search like encompassing a lot of different tools and technologies, including things like personalization.
Mm, okay.
So like, I just want to make sure we're not oversimplifying here, so, but, I think to your point of like how much detail do you want to provide so you can get like kind of a personalized response. Um, so that's really interesting. I do feel like I missed like some parts of the question. So, because, you know, there's many ways you can now personalize, your compound AI system, as we call it at Databricks. You could personalize the generation part, right? So it sounds like you might have been referring partially to that, but you can also personalize the search part. Um, so, some people might prefer to find documents from Wikipedia versus documents from like community forums or internal documents or long or short documents. That's also something that can be heavily personalized. And we have lots of different options for how to incorporate that personalization. So how much of it should you include is also a super interesting question, right? So there's like, how would you actually do the personalization and how much detail should you provide? And this is also super, one, I don't know if I mentioned in my previous chats, but I have some experience doing recommendation systems at eBay. And one of the cool things I worked on there was um, we would basically recommend things for you to buy. So similar to like, if you're using eBay or Amazon and you just bought something, or you're about to buy something and there's a bunch of items that you might be interested in getting. Might recommend things that are other people bought. Like if you're looking, and it's a hard problem because similarity search isn't always sufficient. So if you're looking at like a PlayStation, for example, you probably don't want to buy another PlayStation. It's like, how many PlayStations do you really need? But you might want to buy like a game or like a controller. So, you know, that's, but it can also be confusing if you want to just provide recommendations based on like the person's purchase history. Because when people are buying stuff on eBay and Amazon, these aren't like specialized stores, right? They provide, you can buy like anything, right? So you might want to buy toothpaste and then buy your PlayStation and then buy a car. Like, it's really, you have a lot of, or a house. I don't know. You can buy whatever you want, or some swag. So this history, that's like one type of personalizations that's built into this specific application. And one of the challenging parts of that problem is like, how much weight do you want to provide to previously purchased items, right? So things that were purchased recently, maybe you want to provide more weight, and you kind of have to try to figure out how to disentangle things if someone's buying a lot of things like right after each other. I think if you're just retrieving over your own documents, it's a whole different type of personalization, or you want to provide some snark. That's a whole other kind of personalization, but I can go on and on like this. So is this, am I at least touching on some of the things you're loosely curious about?
No, I think you are. I mean, I think the quick context is, if I was to sort of quickly summarize, is that there are different points in which we can filter or direct how you want to personalize, whether it's at the point of generation or the point of retrieval or
Yeah.
any point in that complex AI system. And I guess the quick context is more a matter of like, how do you find that right balance between being super specific in order to get to, just like you said, that particular document, versus where you want to be a little bit more descriptive to be able to for it to be more imaginative with the responses. I guess that's the upon risking hallucination. Yeah, like, I guess that's one of the context I would ask.
I mean, I could talk kind of still a bit generally about maybe like the philosophy we have on the RAG team or at Databricks. And I
Sure.
think we're really focused on like doing evals.
Okay.
So that, it kind of ends up being the answer to everything. It's like, you just create an evaluation and this will tell you how much you need to do anything. It's
Okay.
kind of
Fair
a
enough.
beautiful, yeah. So, and I think also for the type of RAG that we care about, we don't want to hallucinate too much, but it's such an interesting problem now, right? Because once creativity gets involved, but you basically don't want to. We want to avoid saying too much factual information or any factual information that's not grounded on some type of document. Yeah.
And so on the topic of evals, I know most of the current evals are very generic, but enterprises don't really care about the generic benchmarks. Like, they don't care how well you can complete the like ABCD tasks of HelloSwag. So how do people actually create meaningful eval sets?
Oh man, I don't know. Well, but
Apparently, we really like to
yeah,
throw the hard questions today.
yeah. So what I'm feeling I'm in like a very pedantic mood for some reason. I don't know what it is. I think it's like I did a lot of paper writing recently, so
Fair enough. Fair enough.
I'm like a little hyper focused on saying things that are factually right. So I need to turn up my temperature. I need to start hallucinating a bit. So um, I think the part that I focused on what you said, Brooke, was like something about meaningful evals. So it's like anybody can create an eval, but how do you create like a meaningful eval? And I think one of the reasons I say I don't know is because it's just like so hard to convince people to make their own eval. Yeah, it's just like, it's a lot of work, and I feel like it's super frustrating because you don't know what's a meaningful part. Like, why would someone want to put in all this work if they don't feel like it's gonna push the needle for their application? I will say, like, I when I was doing my PhD, I worked with some people who were like cared very deeply about eval. cared very deeply about looking at data, looking at the model outputs, not just looking at loss curves. And although it can be pretty fun to do that too. And I feel like the things we focused on was coming up with specific capabilities and finding specifically challenging instances, and seeing how models do on those. So I don't want to drift off topic. So maybe we'll treat that as like background. I think that one of the things I'm really excited about these days are using language models to assist in eval. I really think they're great for this problem. Like, it's such a chore sometimes to go through data and like come up with questions, and then it's an additional chore to like check all the model generations and like see how the model did. And it's kind of amazing. Models are like sort of good enough or like almost good enough where you can automate kind of both sides of this quite a lot. So it is kind of something, it's like with great power comes great responsibility type thing so you got to be careful. Like, you got to know that a lot of the, if you're using your model to automatically generate lots of questions and the answers, and then also check if it can generate the answers to those questions, it just, generated both ways, then there's going to be some noise and it's going to make mistakes. But I think within Databricks, we're really looking at ways to improve the technology in the space. In the RAG setting specifically, if you care about things like search, one of the fun things you can do is called question generation. So you can take a document, like any document. It can be some code, it can be like a news article, ask the model to generate like, let's say 5 questions, and maybe do like self-consistency. So like ask it to generate 5 questions 20 different times and take the ones that come up the most frequently, and treat that as like a ground truth for retrieving that specific document. So this is nice because it takes a little bit of the answer generation part out of it, right? Because we kind of know the question is grounded on this document. There are still some problems because sometimes the question is like a little bit underspecified. So if you're like, generating a question for like a mystery, story, and the question is like, who did it? Like, that's just not a very specific question. That's going to, if you type that into a search engine, you're going to get lots of hits to totally random documents, right? So you got to make sure it's like a little bit specific. So there's different things you can do. Like, basically you run retrieval right after you generate it and see if you're getting within ballpark.
And in terms of crafting the prompts, so just going back to like the very initial phases of RAG, I know we haven't even gotten really to the retrieval side. Like, we did prompts, eval, we'll get there. How many examples should you consider putting in? I know you had some recent research about n-shot examples. Do you do 0-shot, 1-shot, 8-shot? Just curious what your general recommendations are in terms of length and descriptiveness of problem.
Yeah, sure. This might be another place where I can get into trouble. So I really love, I like this space a lot. Like, I think it's really cool that we can just like use examples to almost teach the model how to do something, without having to update the model parameters. So you can really, the reason I'll get in trouble is because like I've thought really deeply about this problem. So some things I might say really shouldn't be a general recommendation. They're still very much in like the research bucket. But I'm really a proponent of just starting with like randomly sampling a few examples and putting them in your prompt. I feel like if you're not doing any of that, that's like a great starting point. And you can take that even a little bit further. Like, if you're focused on something like question generation, where it's something you're going to run offline, so you don't have like a big latency concern, then you can sample, let's say, like 5 things to put in the prompt. And you can do that like 5 or 10 times. And this is a way to not only improve the response you're going to get, but get some like diversity in your responses. So that's pretty nice. So also, it's really hard to pick good things. So starting with random is just like, you'll see if it's even like possible to improve things. And again, that's another reason to like try not just one set of random things, but like a few, and see if it helps. Yeah.
That almost feels like the grid search versus random search analogy of like hyperparameter sweeps. So like we all think we're so good about it. Random's just better sometimes.
Yeah, that's so well said. Yeah. If you want to get really extreme about it, you can then try to like do automatic selection, right? So it's kind of, things can get really meta really fast here, because let's say we want to train an embedding model, right? So we've got some documents, like a customer gives us some documents, and they don't have any, they're really busy. They're busy being a Fortune 500 company, and they're really focused on, they have a lot going on, and they don't have clear signal on how to improve their embeddings. So they're going to use a language model to do question generation. And they maybe start by sampling some few shot demonstrations, and they do this a lot. And now they have an implied label. So it's like a fun thing people can like kind of explore if they're feeling more experimental. They kind of know like, oh, this demonstration helps in some cases, and maybe it didn't help in other cases. And now you can even train an embedding model to find demonstrations in order to train an embedding model just to do the task that you're going to care about. So again, I said I could run into trouble, but this is just one example of how you could push this to be a little further. But I'm really supportive of trying lots of different sets of demonstrations. It's like one of the nice intuitions that I've tried to kind of shout in some of my recent papers is that if you're just providing a demonstration that the model knows about, then it might not be like a super useful signal. So one of the things I like to do is try to find hard demonstrations. So anyway, I'll take a pause here, and so I don't get into too much more trouble.
No, it's okay. Don't worry. I'll make sure to cause you trouble another way. So don't worry.
Okay,
I'll take care of
sounds
that.
great.
No, but actually talking about embedding models, one thing I'd like to understand better, we had a side conversation about this idea of fine tuning the embeddings as well. And could you clarify that? Try to explain, because I'm still relatively new to this whole space, and the idea is like, I sort of understood this idea of fine tuning the large language model itself. And you're saying, no, we can actually, in order to improve retrieval, actually fine tune the embedding model. So could you sort of clarify and explain that
Yeah, absolutely.
to somebody like me,
I'm sure you already understand it very deeply. So, but it's super fun that we even have embeddings to play with these days. So, I think I mentioned, right, I've been slowly getting more involved in the IR world, and one of the favorite like information retrieval baselines for search is this method called BM25. So it's like it's been around for a while, I think like 2010 or something like that, maybe earlier. And it's a method that doesn't involve any neural networks. It's based off bag of words, so very simple interactions between tokens. And it's basically measuring like how many words overlap in your query and your document. It has some normalization, it has some things to make sure duplicate words don't like artificially push up the score and stuff like that. But this like really simple baseline for search works really well. And if I like made a tweet joking about how it's such a strong model, and like one of the top like IR influencers on Twitter said it should be nominated for a tweet of the year. It's just like such a meme. It's such a like, everyone in the IR world knows how strong the baseline it is, and it's worth mentioning because I think a lot of people, again, AI world and practitioners often ignore it. It's like such a strong baseline, but it's so effective. Such a simple baseline, but it's so effective. Recently, people realized you can also use neural networks for search. So one of the things you can do is train like an unsupervised embedding. A lot of great deep learning folks have these unsupervised learning techniques to learn representations of stuff, of like text, of images, and they mostly represent some degree of like similarity. So like in the image space, if you were to take a picture of something and rotate it, and you were to convert both of those things into an embedding, you would want those things to be similar. In text, maybe you want like the title to be similar to a document that it came from, or you want to be able to detect paraphrases of piece of text. There's all sorts of ways you can train this model on a large scale with like an unsupervised like objective, but they pretty much represent some definition of similarity or some definition of relevance that you have very little control over. Now, if you're a specialist, right, and you want to include search, so I'm trying to think of an application in my mind, but I don't know, code. I'm using code a lot today. So you want to do like search to help you generate some useful code. And you might start by using something like BM25, or you might start by using one of these like off the shelf, we call them like dense embeddings that come from neural networks that were trained on lots of data in an unsupervised way. You can start with that, but you're going to type in some code, and that's your query now. And if you're not doing this like query rewriting step that I mentioned earlier, you're just going to find other similar pieces of code. And if the code you're writing relies on like some documentation that wasn't mentioned in these like other similar pieces of code, then there's just like no way you're going to possibly find the right information using something that's just like similarity search. And because of that, you're not going to find the key piece of information. So now we're getting back to the things I was mentioning about earlier, where it's like search ends up becoming the bottleneck. So we don't have to get totally stuck here. We have some options now. I mentioned query understanding is like one option. So maybe you can rewrite it and like mention that, oh, I need some help figuring out how to sort lists or something like that. So that's one option. And then something like BM25 or your neural network could have like the chance of finding the right piece of documentation. But that's like a component that you now have to like manage. And that's like latency, right? And in code search, like if you want to generate something, like if you're typing some code, you don't have to like wait a long time. You want, right? Or if you're writing an email, right? You don't have to wait like 5-10 seconds to get like a recommendation on what you want to, write next. So it's good to like remove pieces in this pipeline. So we can just like bypass the query understanding, like the query writing step, by fine-tuning embeddings. So I'm finally mentioning fine-tuning embeddings, which I think that's what the question was about.
Yes.
Yeah. So if you have like a data set of this is the right document for this question, which we know we can use language models to generate, by the way, we could just train a neural network like to match those two things, right? So we don't need there to be any overlapping text between the query and the document anymore. They could look totally different. They could be in different formats. We can just use the typical supervised learning stack, use like contrastive learning. This stuff is used in lots of places, and just like fine tune the embedding to actually match queries to documents that we care about. Just so we have a chance, and sometimes a really good chance now of finding the information that we care about.
And so when would you recommend that somebody fine-tune embeddings? Always? Never? It depends?
Oh, great question. I mean, if I think about it in like the list of things you can try, it's like very high on the list, right? So if you have a RAG application and you want to get better quality, whatever, however you're evaluating that quality, then I would put it very high on the list, because I often think with my IR hat on, and I think of search as like the bottleneck. So it's also like surprisingly straightforward. I think, yeah, folks often, they want to just like take a model and just use it as is. But there's a lot of libraries for doing embedding fine tuning specifically. So you can start with like a pretty good embedding model already, and do some like automatic question generation maybe on your data, and then just like fine tune even a small embedding model. Um, you can just open a Colab or a Databricks notebook and do some fine tuning. So I'm like dancing around the question, but I feel like, yeah, you should just try it. Like I don't think it's like that. It just, if you're able to write code in a notebook, I feel like you should do embedding fine tuning. You can take it further, right? You can like really work on building strong question generation pipelines. You can work on doing like large batch size embedding fine tuning. You can work on mining really good negatives. But you can often get by without doing any of those things. Like you just start with some labeled data, maybe like a few thousand examples that were like just created from a language model, and fine tune an embedding model. And I would be hard pressed to find a specific domain where I don't think that would help. Like maybe things that are like really adversarial, so like really long text, or like things that have, I don't know, just like super strange text that maybe it's like so unusual. I can't even like think of an example, but like like it's like you
Klingon?
invented your own language that
Yeah, I was
doesn't
just like,
exist
if
anywhere.
if I place Klingon in there.
I don't know. Everyone's like into Klingon now, so.
Oh, that's true, actually. Okay, point taken. Okay.
But one of the things that is really funny to me is that there's like this dynamic between embeddings and BM25. So I think some folks might start with BM25 if they're familiar with it, and then see that it's based on this like simple like word matching between query and document. So they'll see like it misses out on synonyms and some basic stuff like that feels like it should, like if you misspell something, it could screw up BM25, right? So those are things where like a neural network would be more like robust. So then they switch to a neural network, but then the neural network misses out on like product codes and like identifiers for, whatever, right? And things that like BM25 would do really well. So I actually feel that if you hit that situation, that is also a really good opportunity for embedding fine tuning, because it'll just kind of, ideally you're teaching the model, like it should actually do this product code matching.
Yeah, and I definitely like your point of retrieval is the crux of this whole system. It's like garbage in, garbage out. Doesn't matter how amazing your 4.0 generative model is if you can't retrieve the right context.
Even if it has a lot of snark. I mean,
Exactly.
yes,
Yeah. And so speaking of retrieval, I know there's also some work done in the field of rerankers. And so
Oh, yeah.
curious to get your take on just pure retrieval versus incorporating rerankers. Like, will this improve the quality of my overall RAG system?
Oh, this is fun. So this is something I work pretty actively on. For folks listening who maybe don't know what reranking is, um, it's when you start with something efficient, like BM25 or dense embedding. These are both representations that are really fast, and they often don't need very expensive models. And so they're fast for two reasons: because the models are usually a little bit more efficient already, and also because they usually disentangle the query and the document representation. So you can pre-compute all of the document representations, um, saving you kind of work at search time. So you start with the fast thing, you get like a list of 10 candidate documents or 100 or more. And now you have like an opportunity to use something more expensive. So because you've already done a lot of the like groundwork. You've already found like, a pool of interesting items. So now you can use like an expensive model to re-rank that list. So re-ranker is basically another term for these like expensive models that are specialized for sorting this like candidate list that came from your first stage embedding or BM25. So I'm kind of like repeating things today, think that both practitioners and folks in AI are kind of like misunderstanding the whole search process. Like they think it's just embeddings. Like maybe they think it's just unsupervised and they don't have to fine tune. Or maybe they fine tune and they're like, okay, we're done. And they don't realize you can do these other things like improve your question generation pipeline. And I think a lot of people aren't jumping to re-ranking because that's now like another component. But it's probably easier to do re-ranking now than it ever has been. So there are now some amazing re-ranking APIs. So there's also a bunch of re-ranking models on Hugging Face that anybody can just go ahead and try. And they can give such a huge boost to numbers like recall and NDCG. Like typically I see something like 10 to 20% improvement on
Wow.
those metrics. So that's like and if we think of search as the bottleneck, so if you're getting like 50, 60% recall at 10, let's say, and then you add a re-ranker, even if it's like a, not necessarily like state of the art, but it's like a decent re-ranker from like Hugging Face, you can probably bump that by 10 to 20%. So now you're at like maybe 60 plus, length from like 50 to 60 recall 10. And I think that's a big bump, right? So I also think like language models are one way you can do re-ranking that people are still like sleeping on a little bit. So I published a paper when I was at Google about using language models for re-ranking, and happy to talk about that. Or
Yes, we'd love for you to dive
okay,
into that.
yeah.
Absolutely.
So again, this is where things can get very meta. So we were so in the IR world, there's been this, people have looked at RAG, right? And they see how retrieval is helping generation. But in the IR world, they're also looking the other direction. They want to see how can language models help retrieval. I already mentioned one way, which is through question generation. And that is like really powerful technique. But you can actually just use the language model already to do search. One really simple thing you can do, and it's kind of mind-blowing how simple it is that you can just have the model output a relevance score. You give a query and a document, you put them both in the prompts, and that surprisingly works a lot of the time. So that's also pretty much what the re-ranking architecture is, by the way. I was kind of hinting at how the re-ranking architecture is like more expensive. The way it's usually more expensive is instead of just taking a query and document separately and outputting something, the re-ranker takes the query and document together and then jointly kind of encodes the information. So it has like more context, it uses more computation because it has like a longer input. And because of all things, like a more expressive model, right? So that's what a re-ranker or architecture usually looks like. The language model is the same thing, right? We're putting the query and document together in the prompt and we're outputting something. When I was at Google, we weren't just outputting the score, we were looking at the logits. So this is a little bit more advanced. Now I think a lot of APIs, sometimes like they decided they're going to turn off logit access for customers. It depends on the company. I think it's just more advanced from like a customer standpoint. People are used to dealing with tokens. There are, token probabilities. That's a whole new thing. But when I was at Google, we incorporated few-shot prompting to make this better. So we would provide examples of questions and matching documents in the prompt. so that when it's generating this relevance score, it had a better chance of getting it right. And we used retrieval to find those examples. So we had our heuristic like retrieval that would find the signal in our retriever was difficulty. So we were trying to find the most difficult examples and include those in the prompt. And we found that gave a bigger, like that would work, that was more effective than random in our use case. So I can even talk about another. Can I preview another paper that I'm working on?
Sure.
Okay, so this is like my first paper since I've joined Databricks, and I'm really excited about it. So
Woohoo.
we had an intern last summer with the RAG team, and we were really looking at the re-ranking problem and trying to understand re-rankers better. And one of the things I think we care a lot about at Databricks are like cost quality trade-offs. So that comes up a lot in RAG and re-ranking, because let's say you use an embedding model and you're getting a good recall at 10 at like 50 documents. So that means you're going to include all 50 documents in the prompt. And that's like a really long prompt now. So it's going to be expensive and slow when you're generating the response. If you could get that same recall with like 10 documents instead of 50, you could end up with a shorter prompt. And that's like where re-ranking can get involved. Even though it's a more expensive model, there could be a good trade-off where you're, using some of the cost on the re-ranker and less so in generation. So that's what we were exploring. But we found something really interesting and surprising, which was that we were like trying to push the boundary. So we were trying to see how many, what would happen if we were ranked not like 100, but like 1,000 or even like 10,000 documents or even like the whole data set. So we're just going to take the most expensive model, which we think about as like richer and like more accurate than the embedding model, and just use the output from that instead of doing this like two-stage pipeline. And we found like the re-ranker was actually worse. So that was kind of surprising. So we saw these two things. We saw one, if we were re-ranking like 10 or 50 documents, that was good. But once we hit like 100 or 500 or like 1,000, it started getting worse, and sometimes would actually get worse than just using the embedding. And then we did this like fair competition where we just like use the re-ranker on the whole data set. So now there's no like two-stage pipeline to cause noise. And we found that even in that situation, things are worse. So the reason I'm so excited about this is because I think this points out people are not only just sleeping on the application of re-rankers, but they're sleeping on like, how do you train re-rankers properly? So I think of this as like a diagnostic, maybe something like loss in the middle, right? Like that was such a huge finding, I think, when people realized that language models, they miss information in the middle of the prompt. And then all the companies and researchers came up with techniques to fix that problem. I think of what we found as like a new diagnostic for re-rankers, where we want to, when you put an embedding head to head with a re-ranker, you definitely expect the re-ranker to be better. So I kind of like riffed, but I'm basically really excited about this paper and just about doing more research in re-rankers. So, but I want to just like say a couple ending pieces here, which is that I do think folks should keep exploring re-rankers, even the ones that are off the shelf now. It's so amazing how you can get an improvement on search, and in many cases, it does make sense to trade off costs for like more accurate search, so you can include less documents. But just be careful, like not too careful, but just like be aware that like this is like kind of a hyperparameter, how many documents you're re-ranking.
And I know my team has definitely applied these tips and tricks that you recommended. One of the fun ones was we were working with a customer. We were using Llama 3.170B for the final generative step. And it was just too slow. We were passing in way too much context in the prompt. And so we took your advice of let's use a language model to assess whether or not the context is actually relevant. So we could pass in less context. And we were able to use a smaller model, like an 8B model, for evaluating that. And so net was it was actually cheaper, faster, and higher quality.
Oh man, I love that. That's so great to hear. And yeah, I mean, I already knew this. We've talked about it, but It's still great to hear again. That's exactly what I'm talking about, right? It's knowing that you even have this option can really make a big impact. So if we had a better re-ranker, you think the team would be interested?
Absolutely.
Okay, cool.
Well, thank you so much today for chatting about information retrieval, RAG systems, and how you can overall get better enterprise quality LLM applications. So thank you again, Andrew.
Of course, yeah. Thank you, Brooke. Thank you, Denny.